Hello and welcome back to part 3 of our F5 Distributed Cloud Fraud Solutions demo series. Are you a fraudster? In our demo, we're going to bring our fraud solutions to life by taking you on our journey to showcase how F5 secures organizations against fraud. We'll emphasize F5's unique market position to deliver the flexibility, superior efficacy, and frictionless customer experience while reducing fraud within their applications, regardless of where they reside, with simple deployment options. By the end of our demo, you'll see how F5 uniquely protects financial services and online merchants with an integrated platform solution that brings security and fraud teams and data together to stop fraudsters in their tracks. In the previous episode, we zoomed in on the first phase of our solution to determine if you're a bot or not. By reducing the noise and preventing the automation that leads to fraud, our solutions then focus on the next phase, which is identifying each transaction within the application to determine the intent and fraud risk. F5's distributed cloud account protection stops manual fraud, and our AI fraud engine uses several main families of features to determine if an online transaction is risky and potentially fraudulent. Using a JavaScript tag, it collects hundreds of client signals per transaction and securely communicates with our API service to obtain real-time predictions on risk levels. The system uses families of proprietary features developed from years of analyzing fraudulent user traffic patterns. We know that any one signal by itself is not a definitive indicator of fraud, but when evaluated collectively, they provide fast, accurate, and frictionless detection. The signals focus on three main aspects: user journey signals and high-risk actions like update password or mobile number, behavioral insights such as copy-paste or the speed of entering a password, etc., and environmental insights. Is it a real browser or device? Is it spoofed? In addition, account protection uses insights from our global network of threat intelligence, insights gathered from protecting over 1 billion transactions per day across a large number of organizations, allowing us to identify new fraud patterns faster using telemetry across our global intelligence network. In our second demo scenario, we focus on the second phase of our fraud solution. Our sample user named Alice is a regular customer of our banking application, and a fraudster has acquired a list of validated, working, stolen credentials and is attempting to access Alice's account and perform account takeover to steal her funds. We'll monitor the fraudster's risk level with real-time user behavior insights, device and user journey signals to determine the level of fraud risk. Then we'll move into the Account Protection Console UI and investigate some fraud incidents like an analyst would do. From there, we'll view the insights regarding the AI decisions of that fraud alert and provide feedback into the system. Quick disclaimer, this demo scenario only covers a small number of our large signal collection set. Now let's see it in action. Now remember, there are hundreds of signals that account protection evaluates. However, this demo will only show a limited set of those. As the user moves around the application, account protection is getting updated signals in real time. Make note of some of the key signals on the page, like number of account attempts, paste actions by the client, interval between keystrokes. Collectively, these all contribute to the aggregate risk score and action through the user journey. Now let's log in as our user named Alice. Alice logs in often and performs weekly money transfers to her sister. So this behavior is seen as normal by our AI fraud engine. We have a slightly elevated risk score, but a very normal user journey for Alice. This transaction has an action of allow. One of the signals that account protection uses to identify risk of fraud is high access diversity. We can see the fraudster with failed attempts to access multiple accounts with the same device ID. The accounts attempted by device signal is increasing, which changes the risk score and recommended action as well. Eventually, the bad actor successfully accesses Alice's account with her credentials. As the fraudster tries to add his new payee and empty Alice's funds, he's presented with an MFA challenge which he cannot satisfy. He's then blocked, and this incident is recorded and presented back to the fraud analysts in the Account Protection Console. The Account Protection Console provides a smart portal for fraud teams to analyze suspicious transactions within their applications, so they can take action quickly and with confidence. We have a filter pre-configured to only display transactions with a recommendation of block or suspicious, and we're sorting them by risk score from highest to lowest. If we look at the fourth line with user Bruce Wesley, Let's expand the fraud reasons. We can see many of the signals that we showed in the account takeover demo earlier. We see many account attempts, pasting text, and others as well. We can also see that in the feedback column there is none yet recorded. Admins can provide feedback regarding whether or not they think a transaction is fraudulent, or an entire user session that includes the transaction as fraud. This enables the AI models used by account protection to more accurately determine which transactions are suspicious and which ones should be blocked. Now let's open up the transaction for more information about the AI decisions behind this event. Looking at the transaction, we see the summary displaying the risk score, recommendation and fraud reasons. The event information has timestamp and URI info, and the user session information is showing the single transaction, but can display correlated events that share the same session ID and device ID. We also notice that the network information shows this transaction from Russia, which is not common for our application. This transaction looks suspicious, but let's go ahead and search our transaction log for this particular device ID and see if it can help our investigation on Bruce Wesley. We've copied the device ID, so let's add it to our filter. After the filter has been applied, we see 6 different accounts from this one device ID, all coming from different IP addresses and ASNs. Let's expand the fraud reasons, and we see many known fraud signals as well. We now have high confidence that this is a fraudulent transaction. Let's go ahead and submit our fraud feedback on this one. Let's walk through one more scenario where we submit fraud feedback for an entire user session instead of a single transaction. On the main dashboard, we see multiple transactions from this Lotus 12 account ID. Let's investigate by opening the transaction. When we look at the information, we see all the correlated user transactions and their associated fraud signals. This is an easy one for a fraud analyst, and we can go ahead and mark the entire user session as fraud. Thanks for tuning in to part 3 of our Fraud Solutions demo series to showcase how F5 secures organizations against fraud using our multi-method approach. Make sure to check out part 4 of our Fraud Solutions demo. Are you who you say you are?